So welcome back to our lesson. So today we are looking for the stationary point. In this concept of stationary point, we are given that y is equal to x cubed minus 3x plus 2. Our assignment is to find the stationary points, and then we determine their nature, whether maximum or minimum points. So we are going to start by finding the dy dx. We differentiate the function that we are given. So we have x cubed minus 3x plus 2. So what is the derivative of this? So the derivative dy over dx will be, so remember when we are differentiating, we normally assume there's a 1 here. So 3 times 1 will be 3x, and then the power that you have here is 3, so you subtract 1 from there. So there's 3x squared minus, when you differentiate this, you assume that this is power 1. 1 times 3 will be 3, and then you subtract this 1 and you'll be left with x power 0. X power 0 is the same as x, it's the same as 1. So our dy dx will be 3x squared minus 3. Another thing that you need to remember is that at stationary points, our derivative dx, dy over dx is supposed to be equal to 0. So at stationary point, dy dx is 0. So for us to get the stationary point, we are going to equate our dy dx to 0 at stationary point. So we'll have 3x squared minus 3 is equal to 0. So we are going to solve this equation to get our dy dx. We are going to solve this equation. So when we are solving this, we are first of all going to factor out 3 because it's common here and here. So we factor out 3 and we'll be left with x squared minus 1 in the brackets. We'll have x squared minus 1 is equal to 0. So from this equation, the first one is 3 is equal to 0. That is when you equate 3 to 0. The next one is x squared minus 1 is equal to 0. But you can simplify x squared minus 1 and it will give us x plus 1 when you expand this, and x minus 1 equals 0. So that means x plus 1 is equal to 0. Therefore, x is equal to negative 1. X minus 1 is equal to 0. Therefore, x is equal to 1. So we have 2 points. That is 1 and negative 1. So we want to get the point whether they are maximum or minimum. We will start with negative 1. So we have negative 1, and we are going to find 2 points, both sides of negative 1. So if kienda huku mbele, you are going to have 0. When you go back once, you are going to have negative 2. So at x is equal to negative 1, that is the stationary point. So we are going to have a stationary point there. When x is negative 2, we are going to replace negative 2 in our dy dx and get the value of dy dx. So this is the value of dy over dx when x is negative 2. So we shall have, for this case, we are going to have 3 times negative 2. We are replacing it here. Negative 2 squared minus 3. And this gives us negative 2 squared is negative 2 times negative 2, which is 4. 4 times 3. That is 12. 12 minus 3 gives us 9. So we are going to have 9. And when we look at 9, our value is positive. And since it's positive, then we shall assume that it is upward sloping. So this one will be upward sloping. And then the other one is 0. When x is 0, what is y? We are going to replace here. So we shall have 3 times 0 squared minus 3. 3 times 0 will be 3, so this gives us negative 3. So our value is negative, therefore it is downward sloping. So therefore this point is going to be a maximum point. Let's check when x is 1 and see whether it is maximum or minimum points when x is 1. So when x is 1, we shall be having, you will come up with a table which looks like this. We have 1, which is there, and then you replace, you can move to 2 and to 0 on this other side. So when x is 0, what is our dy over dx? So you can go to the derivative and replace it with 0. So you'll have 3 times 0 squared minus 3. And this gives you negative 3, which is negative. And since it's negative, that means it is downward sloping. Then we have 2. When it is 2, you'll have 3 times 2 squared minus 3. This gives you 4 times 3, which is 12, minus 3 is 9. So that means this one is upward sloping, and therefore this point is the minimum point. So that is how you find the stationary points for the maximum points and the minimum points.